Good morning, class. Let us start with the next chapter, that is chapter 11, parameter and area. This chapter is also known as mensuration. The pronunciation is mensuration. Why do we call this chapter as mensuration? Because mensuration means measurement. What it means? Measurement. And hence this chapter will going to measure the parameter or area of various figures. Okay. For example, I'll give you an example why we need to measure something. Why the measurement is a need. Understand? For example, you went to the tailor and you asked for your clothes to be get stitched. Yeah. What the first thing tailor will going to do? It will take your measurements. It will take what length, what breadth, everything it will take. He'll measure your complete body, and correspondingly he'll going to, according to your measurement, he'll give the frame to that clothes. Yes or no? That clothes frame will be according to your measurement. Hence measurement is very much required. For example, building a house, you will be provided a plot with the particular area, that this is the area of your plot, and then this particular area only you can build your house. But in case if measurement was not there, is it visible for everything to get at this synchronized and well defined place? No. Hence measurement is very important, and hence this chapter is also very important. So measurement is the need of the world. We cannot live without, or we cannot do the professional work, we cannot do our basic needs even without measurements. Are we clear? So mensuration, also known as parameter and area. Clear? Before that, we need to understand few basic terminologies, that what figures we're going to consider in mensuration. Because it can be any figure, it can be any random figure, but are the measurements, the rules of measurement applicable on that particular figure? That is not quite possible. So hence we need to see basically at what figures, at what definition or concepts relates to mensuration. Clear? The very first definition is rectilinear figure. Rectilinear. Rect means straight. Rectilinear. Linear is also means straight. When you are walking straight, that is what rectilinear figure. Linear, straight, linear, line segment, 180. 180 means straight. Yes, the figure made up of only line segments. The figure made up of only line segments are known as what? Rectilinear figures. So rectilinear figures, line segment, only made up of line segment. For example, triangle. For example, rectangle. For example, square. For example, parallelogram. All are examples of what? All are examples of rectilinear figure. Are we clear? Now, closed figure. But before that, one question for you. What do you think? Circle is a rectilinear figure. What do you think? Circle, a rectilinear figure? No. Condition, line segment. Is there any line segment in a circle? So circle is not a rectilinear figure. It is known as curvilinear figure. Curvilinear figure. Do remember. That is very important. Curved figure. Also known as curved figure. Better name, I must suggest, curved figure. So not rectilinear, it's curved figure. Clear with this? Next, closed figure. Closed means what? You are inside the room and I lock the door outside. What will happen? You are closed in room. That is what closed means. A rectilinear figure which has no free ends. What do you mean by free ends? For example, if we talk about these figures, they do not have free ends. Free ends means they are not open. Any point is not open. If I talk about triangle, not an open point. Rectangle, not even a single point is open, all points are closed. Hence, they are not having any free ends. Free ends means, for example, free, of course I am giving you something. So you take the advantage. So we cannot take the advantage of such figures because they are not closed. Because they are closed. Sorry, they are closed. Because they are closed, we cannot. So, having no free ends. Let me give you an example. A, B, C, D, E, F, G, H. Now see this example. See this figure A, B, C, D, E, F, G, H. If I talk about this particular figure, what do you think? It's a closed figure. No, it's not a closed figure because it has free ends. These ends are free. Anyone can come and enclose this. For example, this happened. So hence this figure was the example of unclosed figure or open figure. So closed figure which has no free end. Understand even closed figure in simple language. Closed figure, if I have to talk about, for example, I started from point A. I started from point A. I moved, I reached back to point A. This is what closed also means. Starting and end point must be same. Starting and end point must be same. Closed figure. This is what is happening. This is what is happening. So closed figure. Are we clear? Next, simple figure. Now figures are simple also. Yes, they are simple also. Try to understand the examples of simple figures, please. With this, I'll give you example of simple figures. Now, a rectilinear figure whose two sides do not intersect. A rectilinear figure whose two sides do not intersect except at a common point. If you see examples of triangle, rectangle, square, all are simple. Why? Because they are not intersecting. They are not intersecting. They are not crossing each other. Intersecting means this, crossing, cut. They are not cutting each other. They are like this. They are like this. They are like this. Hence, they are not cutting each other. They are not intersecting each other. It means all these are examples of simple figure. Triangle, rectangle, square, rhombus, parallelogram, pentagon, hexagon, nonagon, polygons, all are examples of simple figures. Now let me give an example of what you mean by not simple figure, complex figure. Let's see. A, B, C, D, E, F. Just look at this figure. If I see this figure, don't you think these two lines are intersecting? Yes or no? Intersection is there or not? At this point. Hence, this particular part, it shows intersection. Hence, this figure is not simple. It's not a simple figure. We cannot say it's a simple figure because they are, two sides are intersecting. Hence, it is not the simple figure. Though it is closed figure, though it is rectilinear figure. Why rectilinear? Because only made up of line segment. Why closed? Only because there are no free points, no free end. But not simple because intersecting. Are we clear? Now let us start with the next definition, parameter. This is the basic, this is what the basic rule we're going to apply. Very, very important. Okay. Next is parameter. Let's start with the definition of the chapter, parameter. What do you mean by parameter? If I write the word parameter, what do you mean by per meter? Don't you feel it sounds like per meter? Parameter, per meter. Let's see. Let's see. What do you mean by parameter? So if I see parameter, parameter means the distance. The distance around the closed figure. Around the closed figure. Very good. The distance around the closed figure is known as parameter. Let's see. Closed figure. Okay, closed figure. Simple figure. Closed figure. Rectilinear figure. Parameter. Distance around the closed figure. For example, I am having point A. I'll tell you the basic rule how to find the parameter. Whatever the figure is given, select one point. For example, I selected A. Climb on that point. Climb. Now start walking around the boundary of that given figure. For example, I climbed on point A. Now I'll be starting moving around this on the boundary. I reached point B. Now again start moving till you reach the start point. Point C. Reached point D, finally reach point A. This is what parameter is. The distance around the closed figure. The distance around the closed figure is known as your parameter. Are we clear? So, can I say the parameter of the figure, ABCD figure. Let's see, it's a rectangle. I am not writing purposely because you know the formula of rectangle. Parameter is 2 into length plus width. But I am taking very general formula. That is why I am not mentioning the name of the figure. Just I am writing ABCD. I have just given the name. But the hypothetical, which is the real name, that is rectangle, that is I am not getting. So, parameter means distance. A to B, B to C, C to D, D to A. This is what parameter. The length, the distance around the figure. So for example, this is 5 centimeter. This is also 5 centimeter. This is 3 centimeter. This is also 3 centimeter. Now, 5 plus 3, 5 plus 3. 5 plus 3, 8. 8 plus 5, 13. 13 plus 6. 13 plus 3 is 16. 16 centimeter is the parameter of the given figure. Now why centimeter? Let's see. Units used for parameter. Normally, units of length are used. Length units are same as the parameter unit. What are units? What are units? I think in science you already have done in the chapter motion and time in class 6. What are units? For example, I am having my surname. For example, it's Gupta, it's Chaudhary, it's Sethia, it's Fogart, any other means surname I am talking. What is that surname? That's your identity. That's your identity. Yes, you belong to a Gupta family, or you belong to a Chaudhary family, you belong to the Garg family. Similarly, the units are like surname for the numbers. They are like the surnames for the number, which identifies whether that number belongs to the parameter family or area family or volume family. Hence, the parameter units are meter or centimeter, because the units of length are meter, centimeter, millimeter, kilometer, whatever is given to you, etc. But do remember, the unit must be same. In the family, we cannot have different surname. My mother's surname, my father, my sister, whatever, whosoever the members of the family are, their surname must be same. It is always same. Similarly, the parameter, these units must be same. If units are not same, make them same. Are we clear with the parameter? Let me give you the general formula of parameter. General formula of parameter is sum of all sides. Sum of all sides. This is the general formula. Do remember, you can apply this formula anywhere. For example, you forgot the area of parameter formula of rectangle or square, and you stuck. Okay, it is 2l plus b, or it is 2l into b, or it is 2l minus b. You stuck somewhere. So what you have to do? General formula. Climb the figure, move around the figure, get the answer. This is what parameter is. Are we clear? So parameter, this is what parameter is. Clear? Let's move on to the area now. Immediately we'll move on to the area. What do you mean by area? Okay, let's see. I'll give you an example. Area. For example, this is what is the area of your room. For example, you want to place the carpet in the room. What you will do? You'll measure the room. You'll do the measurement. What you'll do? You'll find the area of that room to place that carpet in that room. You'll measure, no? Measurement is required, and hence you should know the area also. Okay. Let's see the next thing. Area. But before that, we need to know about the very important thing. Enclosed space, enclosed, the terminology. For example, I am having this figure with me, ABCD. If I move along this figure, like from A to B, now from B to C, C to D, D to A, finally reached. What I did? I moved along the figure. It means parameter. Now, how I am moving? Just see the style of moving. I started from here. This is how I am moving in the room. means I am covering each and every part of that room. Each and every part. Not only boundary, but I am moving inside. If I am moving on the boundary, that is perimeter. But right now what is I am doing? What I am doing? I am actually moving inside the figure. So hence this interior is known called interior. This part is called interior. Hence area is always spaced enclosed, means interior part. For example, let me, point E is the interior, but point F is the exterior. This is called interior, and point F is called exterior because it is outside. Are we clear? So for an area, it is very important that space enclosed. So what is area? Let's see the definition of area. I hope I am clear with the area, the space enclosed. But if you are moving along the boundary, A, B, C, D, you are moving perimeter. But you are covering that part completely. For example, my hand right now. What my hand is doing? My hand is covering. Let me give you an example. For example, this is my hand. What do you think? My hand covered this much of area. This much is the area covered by my hand. Simple. So this is what area, the cover, the space covered, the space enclosed. Are we clear? So let's see the definition first. Very important. The part of a plane or a region enclosed. The part of a plane or region enclosed is called area. For example, this figure, area of figure ABCD. We know that it's a rectangle. And what is the area of rectangle? General formula, it's length into breadth. General formula, it is not, I am giving the formula for rectangle. Okay. So if this is length, this is also length. If this is breadth, this is also breadth, right? 11. So length it is 2 centimeter and into 3 centimeter it is 6 centimeter. 6 centimeter, centimeter into centimeter, it is what? Centimeter square, because it is multiplied. Hence this is how we find the area of various figures. Are we clear? So area concept is length into breadth. Area enclosed, that is very important. How you close that area, how you enclose that area. I have given an example of my hand. So that is what the area is enclosed. Another example. Let me take another example. Let me take the example of this. What I'll do? Yeah, circular. If I am moving around the boundary, it is what? Perimeter. But if I move like this, what it will be called? It will be called area. It will be called area. Are we clear with this? Any doubt anyone is having till now? So we'll see the next few concepts. What do you mean by rectangle? What do you mean by square? Let's see. Immediately we'll see rectangle and square. What do you mean by rectangle? What do you mean by square? Then in the next class we'll do the formulas related to it. Okay. So let's see rectangle and square. Rectangle, a four-sided figure. A four-sided figure. Four-sided figure, generic name is quadrilateral. Four-sided figure, generic name is quadrilateral. Quad means four, lateral means side. Four-sided figure, general name is quadrilateral. Rectangle, square, rhombus, parallelogram, kite are the examples of quadrilaterals. Are we clear? So, and what do you mean by square? This is what is square. Understand what do you mean by rectangle? Rectangle, opposite sides are parallel and equal. Parallel and equal means if I'm talking, these are opposite sides. They are parallel. AB is parallel to CD and AD is parallel to BC. Also, AB is equal to CD and AD is equal to BC. Secondly, next important point, very important point you should know. Each angle of rectangle is 90 degree. Each angle of a rectangle is 90 degree. Each angle is 90 degree. Are we clear? This is what rectangle is. And hence, the sides are length and breadth. Its sides are called length and breadth. Opposite sides are equal. It means this must be length. This is also called breadth. Are we clear? Now let's move on to the square. Square is simple. Square is a rectangle only, but whose all sides are equal, whose length is equal to breadth. If length will be equal to breadth means all sides are equal. So square are special rectangle whose length is equal to breadth. Length is equal to breadth. Are we clear? So it means all sides equal. All sides are equal and parallel. Secondly, each angle is 90 degree. Each angle is 90 degree means this is also 90 degree, this is also 90 degree, this is also 90 degree, this is also 90 degree. Each side is A. Hence, each side is called edge. Edge of a square. We always say edge of a square. Are we clear? So, till now, we'll complete this only. We'll move and we'll study the various formulas related to this rectangle and square in the next video. Till then, take care and bye bye.